First thing it says to do is on a separate sheet of paper, draw a schematic version of this circuit and then draw simplified versions to solve. So as we fill in this chart, we're going to redraw this circuit until it's fully simplified. Now, is there anything we can fill in right off the bat that we know that we're given? Yes. Voltage of the battery is 9 volts. We know these resistance values. This is 10, 10, 10. Oh, I have this drawn. Wait. Oh yeah, I misread that. This is a 3 actually. I apologize. This is R3 and this is R1. My bad. Okay. And yeah, so when we add 1 and 2, these are in parallel, so we'll have to do the 1 over plus 1 over blah, blah, blah. Okay, so I think we're good there. Let's start to simplify this circuit and see if we can get to our equivalent resistance and all the rest of these things. We've got 2 resistors in parallel right here, R1 and R2, so we are doing 1 over 10 plus 1 over 10. That equals 1 over the equivalent resistance. That's also 2 over 10. And so the actual equivalent resistance, if we flip that, this would be 10 over 2, which is 5. Okay. Now, this is the equivalent resistance just for this little part. We've still got another bit to do. So I'm going to redraw my circuit. Okay, so this is the 10 ohm. This is our 3. And now these together was 5 ohms. And I'm going to fill that in here. This was 1 and 2 together. 5 ohms. Okay, now these are in series. I'm just going to add them. So 15. Sweet. Okay, 15. That's the equivalent resistance for the whole circuit. So that's right here. 15 ohms. Yep. Okay, whole first row done. And hey, look, 2 things are filled in this row. If I know any 2 things, I can find the third because I have whose law? Ohm's law. So we're doing 15 over 9, which I don't love. 0.6 amps. Okay, now let's think back a step. If the current at the battery is 0.6, the current right here is 0.6, then that means anything else in series with the battery will have the same current, which means that our 3 has the same current. So where's our 3? So this should be 0.6. Okay, now if we look at this picture, I see something else. Not only is our 3 in series with the battery, resistors 1 and 2 together are in series with the battery. So this set of parallel branches together is in series with the battery. So the current here is also 0.6. We have in these 2 rows here only 1 empty box, so we can use this equation. So let's see, if we were doing resistor 3, the resistance, we're talking voltage, resistance is 10 ohms and the current is 0.6, so we can multiply those. And what do we get? For this one, we get 6 volts. And same thing for this one. I times R would give us 3 volts. Okay. So the voltage drop across resistor 3, which is this one, that voltage drop is 3 volts. And the voltage drop, is 6 volts. And the voltage drop across this set of parallel branches together, which is this, is 3 volts. Now, something we know about parallel branches is that the voltage drop across each of the branches, which are parallel to each other, will be the same. So the voltage drop across resistor 1 and across resistor 2 will be the same, which means they're both going to be 3 volts. If you know any 2, you can find the third, and so we end up with 0.3 amps, like that. I'm going to leave 11 and 12 and 13 for you guys because you can actually remove them yourselves. Okay, let's go over the last problem, C. I'm going to start by filling in all the things I know already. All of these resistors have a value of 10, And these are all in ohms. These are all in volts. These are all in amps. 10. I see right away 2 and 3 are in series, so I'm going to add them together. So 2/3 would be 20 ohms. I know the voltage of the battery is 9 volts. And I think that's all I can say at the moment. Yeah. Okay, so let's take the next step in simplifying this circuit, which we basically already did. 2 and 3 can be added together to give you an equivalent resistance of 20. So redraw this. Okay, so this is 20, 10. Okay, so I see 2 in parallel, so we can do 1/10 plus 1/20. That would be 2/20, which would be 3/20, so 20/3. Okay, so that's going to be combined 1, 2, and 3, so that's right here. Yeah, which is like 6.67. And then I'm going to redraw that. So this is 20/3, and this is 10. So we just add these two together, and we end up with 50/3. Whoa, what a gross number. And then I guess I can draw this final one. All right. Okay, let's see. Now we've got 2. We can find the third using Ohm's law, and we should end up with 0.54 amps. If we back up to this picture, remember anything in series with the battery will have the same current. So the resistor 4 will have the same current, 0.54. And this, which is 1, 2, and 3 together, this one, will have the same current, so 0.54. And yep. Now I've got this row and this row, and I've got only one missing thing, so I'm going to go ahead and calculate those with Ohm's law. So for resistor 4, we get, and this is easy math, 10 times that. This is not so fun. So we end up with like 3.6 volts there. We know the voltage drop here, right here. We already calculated it. Okay, so this voltage drop across resistor 4 is 5.4. So that means the rest of the 9 volts have to be used up here. So we can do 9 minus 5.4, and that will get us the voltage drop across these 3 resistors together. So the 1, 2, 3, which is what we got, exactly, 3.6. So these two added together give you 9. Okay, so now let's backtrack once more. This 20/3 ohm resistor represents these 2 branches together. And remember, branches that are parallel have the same voltage drop. So if the voltage drop across this is 3.6, then that means the voltage drop across each of these branches is 3.6. So for resistor 1, it's 3.6, and for resistors 2 and 3 together, which is right here, is 3.6. Okay? So let's back up again. Well, actually, let's finish these. We've got empty things in rows with 2 other things. So, and 0.36. Wait, no, that's not right. 0.18. That makes more sense. Okay. Now the only thing left is to figure out 2 by itself and 3 by itself. So let's look at this picture for a second. We know the voltage drop across this whole branch. We found it right here. It's 3.6. We also know the current on this whole branch. It's 0.18. And remember, anything in series will have the same current. So if the current here is 1.8, then that means the current for both of these separately is 1.8. So this is, I'm sorry, 0.18. I misspoke. And then we can figure out this last one. V equals IR, so just multiply each of these by 10. So now 1.8 and 1.8. Okay, there we go.